Hi everyone, welcome back. So my name is Amit and I'm your host, and today we are going to talk about Salesforce DevOps using GitHub Action, and we have a Salesforce MVP Meera Nair with us. So let me hand over her for her introduction and the presentation. Meera, hand over to you.
Sure. Thank you so much, Amit, and welcome everyone to today's session. So today I'm going to talk about Salesforce DevOps using GitHub Actions. And thank you so much, Amit, for having me again as part of Apex Hours. It's a great pleasure to be part of Apex Hours always. So a little about myself. I'm currently working as a solution architect at UST Trivandrum, India. I'm two-time Salesforce MVP and currently leading Trivandrum Architect Community Group. Also, I'm a co-leader of SIMA Group and I'm 90 times Salesforce certified. That's about me. And today we are going to see an overview on DevOps, some of the advantages of implementing DevOps for Salesforce. Then we will straight away move to GitHub Action Basics. Then we are going to see a Salesforce implementation use case. Then the execution details and sample script also that I have used to implement that use case. Finally, we will be seeing some advantages and considerations of utilizing GitHub Actions for Salesforce DevOps. So I think like most of you are having the basic idea of what is DevOps. It is a set of tools and practices normally we follow to make our delivery process or project delivery faster. Because in the earlier times, like when I mentioned, we used to follow waterfall it was taking like 6 months, 1 year to be into production. But with the introduction of Agile, the DevOps is having a great place where you can have very fast deployment to production. And there are some key terms we will be using as part of DevOps, like continuous integration, continuous delivery. I'm sure you all are familiar with all these terms, where the continuous integration means developers will be very frequently checking in their code to a repository. So repository is the key part of DevOps process, any DevOps process. Like you might be using any of the Git versions, like, it can be GitHub, Bitbucket, GitLab. You can use any version, or there are some other tools also available in the market. So when you are having a repository, it is very important to check in your changes to repository very frequently so that you will be able to validate your changes. You can identify your conflicts in advance, and there might be automated validation also happening to the check-in components. And continuous delivery is the next part of that. When you are having a code getting checked in, it is getting validated, getting built, and it is always ready for release to production. And continuous deployment is also coming along with that, meaning you are deploying the build product to your production environment. And another term coming along with DevOps is microservices, where we will be always developing all your components as small services. So earlier, I think in Salesforce, we were not used to follow this pattern, but now with the introduction of unlock packages and all, you have the flexibility to group or package specific features in a single package, and you can deploy that package to different environments. So it is independent of other features within your environment. For example, if you are having a sales process, you can keep it as a package, or if you are developing something to support your marketing process, you can have it as a separate package. So that's the advantage with microservice process. Then other term is infrastructure as code, but it's a generic term, but within Salesforce, we might not be using that this feature that much. But again, there are examples like, when we are developing Scratch.org, using Scratch.org, the automated creation of Scratch.org using your script. That's an example of infrastructure as code. That is, the infrastructure environment for us is the Scratch.org, and you will be able to create that automatically using the script that you are developing. The next part is monitoring and logging. It is mainly to see how good your application is performing. And there are so many tools available in the market to support that. And the last part is communication and collaboration. This is also an important part of DevOps, because when we are implementing a project, there are different stakeholders which are part of that project. It's not just the implementation team, there will be operations team, business stakeholders. So it is important to connect all of them together. And you might be using some tool for your application lifecycle management, for example, Jira. And when you are using DevOps process, there are always possibilities to connect between your ALM tool and your DevOps process so that automatically status can get updated. You will be able to see like as soon as you are checking in something, automatically the deployment might be happening to an environment, and you will be able to mark that particular Jira story as ready for QA or ready for UAT, something like that. So that kind of collaborated environment you will be able to build using a DevOps process. But before deciding how to implement your DevOps solution, there are many factors that you need to consider. I have mentioned some of those here, but there might be many more. One part is the team. Like you might be having multiple projects going on parallel, and there might be multiple feature teams working on different features like this. And the release cycle of each of this project might be different. And it might be utilizing different Salesforce production instance. And there might be different types of implementers, like there might be developers, there might be configurators. So your DevOps solution depends on all these factors. In effect, it is actually deciding your environment and branching strategy also. When I say developers and configurators, for example, the solution option that I am going to suggest or I am going to describe, which is GitHub Actions. For developers, it might be easy, but for people like admins who are not familiar with tools like Visual Studio Code, it might be a bit difficult for them to utilize tools like GitHub Actions. So their preference might be to utilize other tools like Copado or Flosum. So that is also a key factor of deciding what kind of tool you need to use for your DevOps process. Second is your development model. I'm sure you know that there are currently two main type of development model. One is org-based, one is source-based. Org-based means your source of truth will be your production instance. And you will be always creating developer sandboxes for your development purpose. And each of the developer might be utilizing a separate developer sandbox, or they might be sharing the same developer sandbox. This is org-based development, but there are so many issues with that. For example, if two developers are always working on same type of components, or they want to test the same components, then there will be always conflict and there will be issues in completing those stories on time. So in those kind of scenarios, source-based development is going to help us, where your source of truth is going to be your repository always. So instead of depending on the production, you will be using the repository, you will be branching out. There will be a master repository and you will be branching out a development-based repository from the master. And the other time, most of the times now, many of the customers are started to use is this scratch or based development, because it is short-lived, but each of the developer will be able to create his own scratch or for development, so that we will be able to do independent development. So one developer's code is not going to affect the other users or the other developer is developing. That's the biggest advantage with utilizing scratch or based development. And the third factor is environment and branching strategy. Again, this depends on the other factors that I just mentioned. Along with that, like I mentioned, release cycle, when each product or project should go into production. If one project, for example, a sales project is going on, which needs to be in production in 2 months' time, where we have got another project which is on marketing, like lead generation and all those things, that should be in production after 4 months only. So there's a dependency between these two development. So how you are going to manage this dependency, how you are going to merge the changes from one project to other. All this defines your environment and branching strategy. And in addition to this, there might be requirement for hot fixes. For example, you deployed something to production and you found some issue there. It is a critical fix. How you are going to handle that? You always need to have a hot fix strategy. Then there is another term, like, quick fixes or quick hits. We might call it in several names, but there might be small requests from business, which is just configuration changes most of the time. And you might need to get that changes to production as early as possible. Because if you are waiting for a proper release cycle, it might take 1 or 2 months to be in production. So how you are going to handle those kind of changes? And if you are going to very frequently deploy changes to production, how you are going to merge that back to the other sandboxes, or how you are going to retrofit it back to the other sandboxes. So all this actually define your branching strategy. And there might be other factors like, deployment strategy. How you are going to deploy? Are you going to deploy all the components together to your production, or it is going to be a delta deployment? There might be always discussion about around like we should follow a full deployment pattern, or it should be a delta deployment pattern. When you are following full deployment pattern, the advantage is that your repository, you can always make sure that your repository is always going to be a replica of your production instance. So in case of any production issues, you can always very easily restore your production using your repository copy. But when you are doing delta deployments, you are always moving your changes only to the production. So if there are some unnecessary changes, or sometimes, people might be making changes directly to production. And if they are not thinking that back to production, this can be always getting missed in deployments, and it might not be available in your repository. So if some issues are happening, the restore process of your production might not be that much easy. Then testing strategy, like, how you want to execute your testing. You might be getting started with manual, and you need to move to an automated approach. And what are the different tools available? How that is going to work along with the DevOps solution that you are going to adopt. So testing strategy is also a key term in deciding what should be your DevOps tool. And project execution methodology, I mean, like, most of the projects are getting executed in agile methodology nowadays, but there might be a mix of execution. Like sometimes one part of that might be going on in agile methodology, some part might be in waterfall methodology. So how to manage this different project execution methodologies in a single environment. So that's another key factor that you need to consider before deciding your tool. So what are some of the features that you are expecting as part of any DevOps implementation? Of course, like I mentioned, a version control system is the key factor of your DevOps strategy. You should have a repository. Then when you are checking in your code, it is always good to have a code scanning mechanism, so that in case there are some issues with the checked-in code, it can be identified in advance. And automated validation, meaning whenever you are checking in your code to a repository, suppose you are doing development in your own developer environment or your own scratch, or when you are checking in the code to your feature branch repository, from there, if you can validate that to a developer higher environment, that is an additional advantage. You can make sure that in case of any validation issues, the developers can be notified and they will be able to fix the issue. Automated testing, we discussed already, like, whenever you are checking your code, if there can be some automated testing getting executed to make sure, like, whatever you checked in, it is working as expected. That is, again, making your product better. Automated deployment is another key thing. That is, whenever you are merging something to your repository, you are expecting that will be getting automatically deployed to the higher environment. Later, we are going to see everything in action. And this slide talks about some of the advantages of utilizing DevOps, comparing the old development approach. I already mentioned there is a better collaboration between developers and different teams if you are using DevOps, because the normal strategy is that when we are following Agile, each of the developer will be working on a separate user story, and corresponding to each of the user story, they might be creating their own development branch or feature branch. After the development is completed, they might be raising pull requests, or they might be raising requests to merge that to the actual common development branch. And all the developers will be checking into this common development branch. And at that point, if there are some conflicts, they will be getting notified in advance. And they will be able to better collaborate, resolve that conflicts, and make sure that you are not overriding one another's code. That is one advantage with utilization of DevOps. And since we can implement automated deployment, it also helps to keep different environments in sync. You don't take much time to deploy your changes to any of the sandboxes. Because of that, the deployment process will be faster also. And even the retrofit process can be easier utilizing DevOps, meaning once you deploy something to production, there might be many other environments to which you need to deploy the same code or same components. So when you have a repository, it is easy for you because you can directly deploy that repository to other environments or sandboxes also. And if you have code scanning mechanism, it is of course going to improve the code quality of your system. And in addition to DevOps, you might be very familiar with the term DevSecOps. That's also very common nowadays, like how you are making sure the code you are entering is secured without any kind of security violations. So there are so many tools available in the market to support the DevSecOps part of that also, which is going to make sure that your application is secure. And last one point that I would like to mention is the rollback process. Like when you are deploying something to production and if some issue is happening, it's very common that you might need to roll back all your changes. And if you are maintaining a proper repository, you are going to have a previous version of your code, which you can always go deploy to your production and roll back the current changes in your production. And when we are going to discuss the DevOps utilizing GitHub Actions, but of course, this is most of the DevOps process is utilizing DX nowadays. So I hope you know the basics of DX because it's a feature from Salesforce to support the source-driven development approach, which is again command line based. And scratch.org is another feature provided by this Salesforce Dx feature, but it is of course optional. You can't utilize the scratch.org, so you can develop without utilizing scratch.org also. And another advantage is it supports better integration with source control because Salesforce Dx is coming up with lots of CLI commands which you will be able to utilize to easily get changes from your environment. You can easily pull or push your changes to your repository. There are so many commands coming along with DX to support all these activities. Like I mentioned, there are so many DevOps tools available in the market. There are some native tools like which again utilizing the Salesforce platform itself, like the Salesforce product DevOps Center, which is generally available at this moment. And Copilot is there, Flosum is there. The advantage with these tools is that the look and feel is very familiar to you. It looks like Salesforce itself, so anyone can easily adapt to this particular tool and they can work with this tool very easily. You need much. And there are custom built options also available. Like I mentioned, there are Jenkins, Cumulus CI, TeamCity, the GitHub Actions that we are going to utilize. These all are custom built. And there are other products also available, which is not native like AutoRabbit, Gearset. I just mentioned some of this, but there are so many other products available in the market. Now we are going to the basics of GitHub Actions. So this is the high-level framework or architecture of GitHub Actions. Everything is based on events. So what do you mean by an event? You can see, like whenever you develop something within your Visual Studio Code, you might be checking in that code changes to your repository. So that check-in process, what we call it as push operation, it is an event. Creating a pull request to merge that to a higher repository, it is again an event. Push, pull request creation, merging, everything is known as event. And all the actions within GitHub is revolving around this kind of events. So events are the basic building block of GitHub Actions. Then you have workflow. So workflow means it is a configurable automated process that will be running on a specific event. For example, whenever you are pushing something to a repository, what are the different operations should be happening? That will be available in a file, a YAML file. I will show you that later. So that YAML file is known as a particular workflow because the entire script that we have written as part of that particular workflow will be getting executed. The other building block is runner instance. That means whenever you have a workflow defined, At that moment, a PMD scan should happen. That's what I need to execute. But where this is going to get executed, this is not in your machine, but this is going to happen in a remote server or a virtual machine. So you need to instantiate that particular remote server, and you should be installing all the required components to that particular server before getting started with your process. And you can use Ubuntu, or you can use Windows or Mac, anything you will be able to configure. The other is job. Job means each discrete operation that you are going to perform as part of your workflow execution. Like I mentioned, when I'm checking in my component, automatically I should be running a PMD scan. That PMD scan is known as a particular job. Within that job, there will be separate steps. Like I mentioned, you need to instantiate the server. That is one step. You need to install Salesforce CLI there. That is next step. You might need to install PMD related components to that server. That is another step. So a single job is consisting of multiple steps. And each of the job, you can see that here, each job will be getting executed in a separate runner. So if a workflow is having two different jobs, that will be getting executed sequentially utilizing different runners. Those are the basics of GitHub Actions. Now we can see that in detail. For that, this is what we are going to demo as part of today's GitHub Action demo. So this is a sequence of operation that is going to execute, and some part of that we are going to automate. The first step is that, like we all do, we will be developing in our Visual Studio, and we will be checking in our code to a feature branch. This is going to be a manual operation. Then when I am checking in my component to the repository, at the backend, I have to automate the run of PMD scan. That is first automation. And if that PMD scanning is success, I need to automatically create a pull request to merge my feature branch changes to the master. This also I would like to automate. Now, the next step is, whenever we are creating a pull request, that is, you want to basically merge your feature branch with the master. At that moment, I would like to create a scratch org and deploy my components to the scratch org. This is basically to make sure that whatever components that I am going to deploy is valid. There is not going to be any kind of validation or validation issues happening when I am trying to deploy this to my actual environment. So this is the next step. And once the scratch org creation is complete, you will be able to run your test classes there. This is again automated. Once the scratch org is created successfully, you have run your test classes, and if it is success, the next operation that we need to do is approve the pull request and merge it with the master. Execution scenario, a developer will be raising a pull request, and there will be a reviewer assigned to that. Someone should review the pull request to make sure that the components checked in are valid, or it's a kind of code review process that we need to execute. So when you're approving a pull request, basically at the backend, the code that the developer is checked in is getting merged to the master repository. And at that moment, I need to deploy the components to another org. In real world, it might be your system integrated testing environment, or it can be UAT, but you need to basically deploy this to a higher environment. That is the next step. So these are the things that we are going to implement or execute as part of current DevOps strategy. Let me go to my repository. Because of the sharing, I think some part of the browser is covered. So give me a second. So this is a trial repository I created, and you can see a master branch is there. And from this master branch, I created some feature or child branches also. And demo branch is the branch where we are going to do our development. Now, let me open my Visual Studio. all the files that you have created for your DevOps purpose, GitHub DevOps purpose, it will be residing under a folder called GitHub Workflows. So if you expand this, you will be able to see multiple YAML files that I created for different purpose. So we will be getting started with this file, which is push to feature, meaning this is a set of actions that we are going to execute when I am pushing my change to a feature branch. Like we have seen in this, the first thing that we need to do is a PMD scan, and after that you need to create a pull request. This is a structure of a YAML file to support GitHub workflow. There will be a name for the file, and then you are going to mention which is the event on which this action is going to get executed. So we need to execute this particular workflow when we are performing a push operation to our demo branch. So the operation is push, and the branch in which this is going to get executed is demo branch. You can see I'm currently connected to demo branch. You will be able to mention multiple branches also here, because normally each of the developer might be working on multiple branches. So either it can be like, you can mention the pattern of your branch, or you can specify the specific names of the branches itself here. After that, your job will be getting started. So like I mentioned, each of the job, currently this job is PMT run. That is my job name. Inside that job, I am going to have multiple steps. The first step you can see is I am going to check out my code to the server. So the server, all my code that I checked in will be available there. And next step is installing the PMD, because this is a remote server. All the framework or all the components necessary to execute our action should be installed there. That's what you are seeing as the next step. And after that, you can run your PMD scan operation. So to execute the PMT, I have got a folder here where I have mentioned all the rules that needs to be executed. So it is already configured. You will be able to modify it based on your requirement. So that's what getting executed. And once the PMT scan is success, you can automate the pull request creation. Now you can see I'm utilizing something called action/checkout. Also, you can see I'm utilizing some additional already existing workflow actions. So similar to Salesforce is having App Exchange, GitHub is having also a marketplace. From that marketplace, you will be able to utilize already available jobs that others have created, which is reusable. So this checkout is that kind of action which is already available. Similarly, later also you will be seeing I will be utilizing existing actions from the marketplace. This creation of a pull request also an action from the marketplace that I am consuming directly. But along with that, there will be some kind of token you might need to create. This is specific to my repository. You will be able to generate that in your repository and store it as a variable. So this is what is going to get executed when you are actually pushing changes to your repository. Now, when we are creating a pull request, what is the next action that we need to do? For that, I have created another YAML file. And as per our requirement, when a pull request is getting created, we need to basically create a new scratch org, deploy all our changes to this scratch org, and execute the test classes there. That is the next step, getting executed as part of pull request. So here you can see again PMT scanning I am doing as part of this process also. You can always skip that. And here you will be creating scratch org. For that, again, you need to check out your code and you need to install Salesforce CLI. And you need to basically authenticate the Dev Hub from which you are going to create the scratch org. For that, you will be utilizing some variables like what is the Dev Hub URL that you are going to consume and the access credentials for that Dev Hub environment. All this will be configured under settings, and there's something called secrets under which you will be able to store all your variables that you need to utilize as part of your GitHub action workflow. You can see the DevOps Dx URL I configured here already. So once the Dev Hub is authenticated, so here you can see we are directly consuming SFDX command to authorize an environment. Once that is authorized, you will be again utilizing SFDX command to create a scratch org. And after that, we will be pushing our repository changes to that particular scratch org. We will be running the test classes there. And once the test class is run, there will be a file getting created with all the test results, and you can delete this temporary file after that, and you will be able to delete your scratch org, because this is a temporary scratch org that you created just to verify that the component installation is going to be success. And again, I forgot to mention one thing. You will be able to get all the sample code from Salesforce labs itself, because Salesforce labs are having lots of sample projects, and everywhere they will be utilizing GitHub Actions itself for their internal deployment purpose. So I got all the sample code, sample applications, and all the process from the Salesforce lab itself. I can share the links for that particular projects later. So maybe at this moment, since we have seen the code corresponding to PMD validation and also the pull request and scratch org creation, now let us try to implement this. For that, what I'm trying to do is I have got some code or Apex class available here called account list, and I'm going to make some changes to this particular class at this moment. Just not any code change, just I'm adding a comment. Like you can see demo Apex hours. I'm changing this locally, and this is the environment that I am connected to. This is my demo developer edition. And currently you can see the comment just there just says demo. Now, since I have changed this here, let us deploy this to the environment. This is my own developer edition to which I am currently deploying. You can see here that I am connected to my developer edition, and the deployment seems to be completed. So I'm just refreshing this to see or verify the comment, whatever we have entered is available in this org. You can see the demo Apex hours comment is available, reflected in my org. And you can also see the change is available. And let me actually stage this change and commit this. Maybe I can just mention like, user story 111. This is the comment I'm going to enter for this check-in process. So I commit, we can push this to the remote repository, because currently the change is available just to my demo branch locally. Now I want to pull this to, push this to my remote demo branch repository. So that's what I'm currently doing. Seems like the operation is complete. So you can go back to the repository. So you can see my demo branch is having a recent push. And now we can go to actions. So actions is the place where all the workflow files are going to execute. You can see this was the comment I have provided, user story 111. So the first operation is going to get executed here. So if you remember, the action that we were trying to execute as part of initial file was automated PMD scanning and creation of pull request. You can see both operations got completed. And if you want to see the details under each of this job, you can click on this and you can see each of this mentioned here is different step as part of each of job. So install PMD, run PMD, you can see all the actions getting executed as part of PMD scan. And after that, you can see the pull request got executed. So how you can verify that this pull request got created successfully? For that, you can see the pull request. You can go to the pull request tab and you can see the pull request got created automatically. Now we have a second operation happening when the pull request is getting created. That is the scratch org creation and deploy your components to scratch org run test class. So you can open this action and you can see I had a PMD run there also that got completed. And if you open the scratch org testing, you can see it's most of the operations got completed already. So it is deleting the scratcher and the action also got completed. Meaning you created a scratcher, deployed your components there, run your test classes and verified that everything is working as expected. Now, what is the next step? I need to approve or merge this pull request to my master branch. Currently, the changes available in my in my feature branch. From there, I want to merge this to master. The pull request is to merge to master. But as part of that, when I'm merging, again, I have got some additional operations happening as part of my workflow file, which is deploy. Here, I'm just deploying the changes. So the operation is going to happen when a merge operation is happening in the master branch. When you approve a pull request, basically it is a push operation to the master branch. So on push to the master branch, we are going to deploy your changes to another environment. So I have got a second environment. This is another developer edition I am utilizing, and you can see the account list, the same class exists there also, but it does not hold the changes that we currently implemented. So my request is that whenever I am merging the change to the master branch code change should get deployed to this particular new environment. That's what we are trying to implement as part of the workflow. For that, now let us go ahead and merge the pull request. Let me open the pull request. Like I mentioned, normally there might be a reviewer. Since this is my own private repository, I cannot add any other reviewer. So I'm automatically, without any approval process, I'm directly going to merge this pull request to the master. So merge operation got completed, and we should have one action getting executed on merging of this pull request. So what it is going to do is it's going to deploy the components that got checked into master to another repository, another environment. It's getting executed, it's authenticating the second developer environment, and now the push operation is happening. You can see the components got deployed successfully to my second environment. So let me quickly refresh the code inside the second environment and see if we are able to see the command change that we made in our Visual Studio. Okay, you can see the new comments are available here. That means the code got deployed successfully to the second environment. So this is a basic flow that I try to implement in the real world. You might be having additional complex process getting executed on top of this, but this is a very minimal flow that we try to implement utilizing GitHub Actions. So there are some advantages with this GitHub Actions compared to other operations, like it's easy to implement because many of the process or the action script which we need to execute are commonly available. Like I mentioned, it is available in Salesforce Labs itself. You can easily copy that and modify it based on your requirement. And other advantage is that you will be able to reuse actions which are available in the marketplace, GitHub marketplace. So we already we utilized pull request creation from marketplace. We used something to check out the code to the server. All these are like commonly available that we can use from the marketplace. And the execution is faster. You have seen like how fastly it got deployed to a second environment. And you can have condition-based actions also. Now I haven't added any condition, but you can have additional conditions. Like if the PMT scan is failing, you don't need to create a pull request. Or if the source code or the scratch or creation got failed, you can stop the operation there without merging that to higher environment. And you can also implement Jira integration also. Like if you are utilizing Jira, you can have additional script statements there to update Jira issue status based on the deployment or the update to your pull request. or when you are merging something to the master branch, you can update your Jira issue status. That is one advantage. But there are some additional considerations that we discussed. And this implementation actually needs people with good experience on Git actions or Git commands, and also they should understand Salesforce metadata. So most of the time we might need a proper DevOps person to implement the flow for you. And based on your requirement, like when the team is getting expanded, when you are having additional process in place, the script needs to be maintained by someone. And one problem we are currently facing with GitHub Action is that the retrofit activities is really time consuming, because whenever you are trying to merge after a production deployment, you might need to merge that with lower branches, which might be deploying these changes to other sandboxes also. At that moment, there are higher chances that there will be conflict, especially when you are deploying profiles, permission sets, etc. There will be conflicts for sure. So solving this conflicts is most of the time is not straightforward. You might need to put lots of extra effort to solve those issues. And sometimes after a production deployment, we may take up to 2 days to complete this merge conflict resolution and deployment to other environments. And like I mentioned, it is suitable for developers, very suitable for developers, because we are utilizing Visual Studio Code to check in all the components. But when you are having a support team who will be taking care of production issues, or there's a QKit team who does not have proper understanding of Visual Studio and have to utilize the SFDX commands, it might be a bit difficult for them to utilize this option. And these are some of the resources that I referred for this session. I can share these links later. And if we have some questions, we can take that. And thank you once again, Amit, for this opportunity.
Thank you, Meera. I can see some question into the chat window. So you want to read out or you want me to read out?
Okay, let me take a look. Okay, the first question is related to Jenkins is independent of the repository being used in the project. Can we use GitHub Actions with, say, Bitbucket repositories? Okay, so GitHub Action is specific to GitHub. Okay, so if you want to implement it for Bitbucket, that won't be working because this is just specific to GitHub. And similar to this, I think GitLab is another repository type that you are using. GitLab is having its own feature called GitLab pipeline, I guess. So whatever I explained, it is just to be used with GitHub pipeline actually. So the next question, any insight on how to handle merge conflicts with massive files like profiles when GitHub is used as DevOps tool? Good question. Like I mentioned, this is the most difficult side of GitHub Action, or I guess anywhere we are going to same challenge, how to handle merge conflicts. So like I mentioned, most of the time we are taking up to 2 days to resolve all the conflicts, because that involves actually involvement from all the developers who worked on that particular source and destination environments to resolve the conflict. So there is no easy approach to solve the conflicts existing in the system whenever we are trying to merge something. Next question is, how can Scratch.org be used while working on features with a high dependency on other applications like Oracle CPQ or inbound outbound integrations with other? Okay, so Scratch.org, utilization of Scratch.org, you might need to be very careful to decide whether you need to use Scratch.org or not, because in the past also we were using Scratch.org based development for almost 2 years. There are advantages and disadvantages with that, because Scratch.org, like you all know, we always have a limitation of components that can be deployed to a particular Scratch.org. You cannot deploy entire your repository to a Scratch.org for development. Most of the time, you might have to divide your features into separate packages, and you just deploy that package to your Scratch.org and continue with your development. And most of the time, there will be components which is common to multiple features. In that case, you might end up in creating a base package which is applicable to all the different features, and you need to deploy that to your scratcher. And when you are having high dependency with integrations, outbound integrations, external system, it's better not to use scratcher. That's what we used to do. Like for independent internal developments, it is always safe to use scratcher, but there might be additional complexity when you are having integrations. Yes, it's better to avoid. What are different approaches to resolving conflicts? So it's specific to the tool, I guess. If you talk about GitHub, what we have seen, simple changes in the directly in GitHub environment itself, we are getting an option to resolve that. Otherwise, we will be utilizing Visual Studio Code. You need to compare and, change the files, or, if you have two files which are conflicting, one is the current file where you are implementing, the other file is like the one that you want to merge to your current file. So like I mentioned, most of the time we will have both the developers sit together, go through the changes incoming and what is already existing, then decide on what should be the decision on what to be merged. So it's not a simple process.
It's a manual.
It is manual operation always. That's what I have seen. I'm not sure if people have got any other options to resolve conflicts. It's most of the time manual. That's what I have seen.
Okay, thank you.
Any other options you have seen?
No, actually, no. Anyway.
Yeah, it's always difficult actually.
Yeah, definitely. Yeah. Thank you.
Yes. Yeah. Will this repository be shared? Yes, of course I can share. This is a public repository. How to set up the actions? Do we just need to have the YAML files in the repository or some separate? No, you just need to have the YAML files. Like I mentioned, it is event-based, right? So you are mentioning your, sorry, okay, some issue with the sharing, but that's okay. But I hope you have seen that already. It's event-based. All the actions are event-based. You can mention like on which operation your action should get executed. So in the YAML file itself, you will be able to mention that there is no additional scheduling needed, but I guess there are options to schedule also. Next question is on Jenkins. Jenkins is independent of, okay, I think we covered that already. That command which can help you. Okay, Amit. Thank you for that. GitHub Action is available freely for public repositories, while private repository it has a cost component associated with it, which becomes a major bottleneck to implement since a lot of clients host their GitHub repositories as private. Okay, yeah, I agree. GitHub Actions is available freely for, okay, same statement. Yeah, all repository utilization of this, so everything is come with a cost always. Can we automate to run test classes while merging our pull request into target branch? Yes, I think I showed that already. Like we will be able to run a validation along with test class execution when you are creating the pull request. So that's a validation option. I think I showed another approach of creating a scratcher, but in our project, actually, we implemented the same. When a pull request is getting created, we are actually executing a validation and run of test classes to verify that everything is working. Can you also share learning path for these tools and related integration? So it's not very complex. For my learning purpose, I think I just took 2 to 3 days to understand the basics. I think I already have that link added in this resources. It's the GitHub documentation itself. So there is a quick start available. You can refer that. It contains all the basics and there are sample code also available. But like I mentioned, please refer to Salesforce Market, Salesforce Lab projects where you will be getting more sample codes. I reuse code available in Salesforce Lab. Yeah, same thing, same link. I will be sharing all this. I think Amit will be sharing this later. So you can refer these links to learn, especially just quick start.
After this session, I will be share the presentation and the recording, everything on Apex our YouTube channel. So you can refer this link over there.
Thanks, Amit. Any additional questions?
Thank you, Mira, for such a great session and jumping on the session quickly within a week. Thank you so much and spending your time over the weekend.